Hi, everyone. This is just a quick overview of the finding a location lesson. Hoping to cover this in class, but for those of you at home, just a quick overview of what's on the slideshow. So first of all, in class, we would have talked about what is geography. The fancy sort of definition is a study of Earth's physical and human systems and the relationships among them. But in a practical sense, what is where, why is it there, and why do we care? That's sort of the essence of what we do as geographers. We're always looking for patterns. We try to simplify the world into, for instance, maps and to break things down into regions and then take a look at the pattern that develops and then go, okay, well, here's the pattern. Why do we think that's happening? And ultimately, why would we care about that pattern? So, as people who are looking for patterns, we have to describe where things are. And the most basic way of describing where things are is through using relative locations. So, for instance, you're out traveling and um, you're down south. Nobody knows where St. Catharines is, but you can say, well, do you know where Toronto is? And the people are like, yeah, I've heard of Toronto. Well, that's in the province of Ontario, which is in Canada, which is in North America. So it's a way that you can sort of narrow down where you locate by saying what's close to you or what sort of regions you're within. So, for instance, the Eden High School is found within the region or the municipality of St. Catharines, which is in the region of Niagara, which is in the province of Ontario, and so on. When it comes to hemispheres, we've divided the world along the equator to divide it into a northern and a southern hemisphere, and we can also divide it in the opposite direction along the international date line and the prime meridian, which divides us into an eastern and a western hemisphere. So, when you're trying to describe your location, you can use the compass rose in order to suggest where other locations are. So if you stand down at Lake Ontario and you stare across the lake, you can actually see on a nice clear day the CN Tower of Toronto. So that's the city to the north of us. If you take the 406, that heads south and you come across the community of Welland. If you take the 401 heading in this direction, which is west, you're going to Hamilton, and Niagara on the Lake is to the east of us. So I've used the compass rose. And what are the cardinal directions? We've got north, east, south, and west. Those are what we call cardinal directions. Every other direction is what we call ordinal directions. So northeast is halfway between north and east. Southeast is halfway between east and south, and so on. When it comes to dividing up even further, halfway between north and northeast is north by northeast, and it's at 45 degrees, which is halfway between these two directions. East by northeast is halfway between 45 degrees and 90 degrees, so that would be what, add 22 and a half to 45, so that would be 69 and a half degrees, and so on. We just keep adding um, as we go around the compass rose here. So, what's the purpose of latitude and longitude? Well, it allows us to give an exact location instead of a relative location, which gives you a ballpark idea of where things are. If I want to, I don't know, let's say I want to build on my property, I need to know exactly where my property line is, and you could use latitude and longitude in order to do that. But there are some key uh, lines of latitude which run east-west um, that have a special significance. So, for instance, the Arctic Circle. Above the Arctic Circle, at some point in time during the year, you're going to experience 24 hours of darkness or 24 hours of sunlight. The Tropic of Cancer indicates uh, the furthest north that you can go and still have, at some point in the year, the sun directly over top of your community. Whereas the Tropic of Capricorn is as far south you can go, and still have the sun directly over top of you. And of course, Antarctica would be, the Antarctic Circle is where you're going to experience 24 hours of sunlight or 24 hours of darkness um, in the south. So latitude starts at the equator. It's exactly halfway between the two poles, and it divides our planet into a northern and a southern half. There's the equator right there. Now remember, it's an imaginary line. You're not going to trip over this as you're heading down towards the Brazil or the Congo. It's just this line that we have determined to be exactly halfway between the two poles. Now, the key thing about latitude and longitude is, as you can see, throughout the year, our planet revolves around the sun, and as we go around the sun, we'll notice that the planet is tilted. And at this point, you'll see that the sun is directly over the Tropic of Cancer. And at this point, it's directly over the equator, and here it's directly over the Tropic of Capricorn. So this indicates when we're going to have lots of sunlight. So for instance, the Northern Hemisphere, lots of sunlight because we're tilted towards the sun. Equal amounts of sunlight and darkness. And then finally, we're pointing away, and therefore our coldest months. So that's just our winter. How can you find your latitude? Well, I'll show you this in class. I'm not going to get into it on the slideshow. Longitude, on the other hand, far more difficult to calculate. It took us literally thousands of years after figuring out latitude how to measure longitude. Basically, we've divided the world up so that we also have 24 sort of key time zones, each one being an hour apart, and they match up with the meridians. And these are all of our meridians. They all meet at the North Pole, and they all meet at the South Pole, unlike the meridians of longitude, which are never going to cross each other. They're parallels. So how do we find latitude? Well, we start at the equator, and we read up or down depending on where the location is, and then we read the longitude. So for instance, if I'm trying to figure out where A is here, I start off at the equator. All right, so the equator, and I go up 30 degrees, 60 degrees, so it's at 60 degrees, and because it's above the equator, it's at 60 degrees north. On the other side of the coin, when it comes to longitude, we begin at the prime meridian, and we head in this direction, which is west, and it's right on the 90 line, so that would mean it's 90 degrees west. Sometimes, though, we have locations that are not right on the line. So F is an example of that. So in the case of F, we start at the equator. We go up 30 degrees. It's not on the 30 line, but it's not quite to the 60 line. It's a little bit past halfway. Now, halfway would be 45 degrees. So a little bit more than that I'm going to estimate at about 50 degrees. So since it's above the equator, it'd be about 50 degrees north. That would be about the 50 line right there. Then we go to longitude. We start off at the prime meridian, 30, 60. It's between 60 and 90. And it's a little bit shy of halfway. Halfway would be, 75 degrees. So a little bit shy of that. I'm going to say is about 70 degrees. So we said it's 50 degrees north and about 70 degrees east. Great video here. Basically, this is a group of people petitioning the president. The president doesn't sit in on presentations because he doesn't have all the time in the world to do this. So quite often he sends his aides. These are his aides listening to a presentation about how America needs to change all of its maps, and why would anybody want to do that? So enjoy it. It's really worth listening to. Ultimately, what they're suggesting is this Robinson map is a far more accurate way of depicting the shapes and locations of the continents compared to the old Mercator, where we've got these heavily distorted places towards the poles. Basically, these circles here are indicating the amount of distortion. So you can see at the equator, there's, all the circles are the same size, but as we go further north, the circles get bigger, which means anything getting towards the poles is a lot bigger on a Mercator map, which is not the truth. All right, so you're going to read through those pages in the textbook and do the questions, and that's it for the slideshow. Whoops, I shouldn't have done that. Oh, one other thing. When it comes to the textbook reading, you click on the textbook reading. Notice here this little rotation button, and if you can't read it, use the plus minus buttons. All right, so this will change the magnification so you can read it better. All right, and you can scroll up and down and across in order to see it. Quite often, it's easier to open it up on a new page. So where are we here? Nope. In my case, I've got that button. I'm not sure if you had that button. I think you have to open it up in a new tab. All right. So whenever you have a PDF document that's rotated the wrong way, just hover over top of it, and those will help you out. All right. Best of luck.